So good morning, everyone. Today we're going to learn about quadratic equation, how to code a quadratic equation in C that will help prompt a user to enter the coefficients of A, B, C, the format of a quadratic equation. So when the user enters that A, B, C, they're going to be given roots. They're going to be given roots, either real or complex. Both of them will come depending on the ABCD coefficients. So as the as the C programming language, you have to include this. You all know the syntax of the C programming language, but since I'm going to use math, some equations in math, I'm going to include the math file. For a start, we're going to, the int, the main structure of the computer, of the programming, of the C programming language is that int main as usual. So we're going to assign, we're going to declare variables. For a start, we're going to declare the ABC because we're going to use them. Then we're going to declare, when you're declaring multiple variables, you use the double word. Then second, we're going to declare the other variables, the discriminant, because we're going to use it. Then the first root, the second root. Then we're going to declare whether it is real. In the complex root, we're going to declare the real part and the imaginary part as it is already laid out here. So for example, for the first function, we're going to prompt a user to enter the coefficients of A, B, and C. And to start with, we're going to ask them to enter the coefficients of A. A must not be a zero. So we're going to include that in the statement as we ask for that information. We're going to include that enter coefficient of A, which is a non-zero. You tell the user. And of course, you give placeholders for that. And for example, some users are big-headed. So in case someone puts something that is a zero, then you will tell them that the coefficient cannot be a zero. Please enter something that is not a zero in that way. While then that function will be done for that case. Now the while the coefficient of that is non-zero. So we go to another function. For example, while the coefficient of A is equal to 0, we proceed to ask for the coefficient of B. You get. So we'll be like enter B, then the user will be prompted to enter B, which is this scanf file. This scanf function that will ask for will create space for the B that is going to be entered by the user. And then the same for C. Now that function will be done, and we'll go to the next thing. We'll be going to the discriminant. Since we already declared the variable discriminant, now we have to come and assign a value to that variable, which is the discriminant formula, according to the bulldozer formula. It is b squared minus the discriminant is that small function under the root in the bulldozer formula. It is that function. Now it is already laid out here, which is b squared minus 4ac. 4ac, okay, 4 times f times 4 times f 4 times a times c, which is laid out here for clear viewing. I've put comments in this work, so anyone that wants to read it, you can follow up and keep track of whatever in case you don't understand my audio. So we come to give more parameters to the discriminant so that we filter out whether the roots are real or whether the roots are not real, they are complex, and then we go on and so forth. So the first function in the discriminant will be like if the discriminant is greater than or equal to 0, that value under the bracket is greater than or equals to 0. Then we come down. The real part will start with the real in case it is real. That is if the discriminant is greater than 0. Because if it is greater than 0, then you get a real number, not a complex number. If it is not 0, you get something greater than Then you can carry on with the bull. You know all the boulders. I will not teach it right now. I believe you know the bulldozer, so you can fill it in. If the value under the bracket is greater than 0, then you get real numbers, real roots. So we're going to first work with that. If the discriminant is greater than 0, then root 1, will give it a formula. Root 1 will be equal to negative b plus or minus, because the answers are supposed to be 2. So one will take the plus part, then the other will take the minus part. The square root of the discriminant, divide by 2a. Divide by 2a. Then the other thing would be we get the second root. In case the discriminant is greater than 0, you have two roots, two real roots. So the first one will be this root, then the second one will be this root, because you have to change it to a negative. So they have to be the same. There are two, they could be the same or different, but one has to be a negative, one has to be a positive. So after declaring after assigning values to our variables root 1 and root 2, because root 1 and root 2 were our variables. Now we're done assigning values to them. Then we'll prompt the user. We'll print out if the conditions are filled. We'll print out that the first print statement will be the roots are real. We've identified them that they are real because it is greater than 0. The discriminant is greater than 0. Then after saying that, after printing that out, just to inform the user that the roots are real, then we'll print them out. We'll print the roots out because we've already computed the work. Now this will print the root 1 is equal to this placeholder. Then we assign it to root 1, because we assign it to root 1. Then the second root, of course, if they are root, if they are root, they will be 2. Then we assign it to root 2 here, as you see. And that function is done. Else, if it is less than 0, if it is equal to 0, sorry. If the discriminant is equal to 0, remember at the beginning of the main function, we were like, if it is greater than or equal to 0. Now we started with a scenario where the discriminant is greater than 0. Now, after that, we're done with that part. When it is greater than 0, we'll look at when it is just equal to 0. If it is equal to 0, if you know the math of that quadratic equation, if it is equal to 0, we have the same roots, but there will be 2. The bit 1 will be negative, 1 will be positive. Now we'll come and implement that. Then root 1 will be equal to root 2 in that case, which will be equal to negative b divided by 2 times a. So after that, after computing that, we'll come and print it out that the roots are real. Yes, we inform the user that the roots are real, and after informing them, we'll tell them the roots one by one, that root 1 is equal to root 2 is equal to that. Hope we are following. Then we come back to the else part. Now this else part is on the same alignment with the first if function, the main if function. Besides these that were inside that if function, it is the else part. So the else part works with the complex. If the roots are not real, of course they are complex. Now we'll come and implement the fact that if they are complex, we'll come and implement that. Now in that else part, you tell the user that it is the complex roots. So you have to come and compute them. For complex roots, we have the real part and the imaginary part. So for the real part, you'll have to create a formula for that, which will be real part is equal to negative b divided by 2 times a, sorry. Then the imaginary part will be equal to the square root of the discriminant, then divide by the 2a. And then after that, we'll print out, because we already have root 1 and root 2, which are already complex and having two parts, the real part and the imaginary part. Root 1 will be equal to this. Then we assign back to the variables in which you're picking these placeholders. And then root 2 will be equal to the same thing. And then you'll be done with the program. You'll be done coding your program. And of course, since it is a C language, you have to close it up with the return 0, and then you do as you're supposed to do everything.
It's doing. Already turning into lecture.
Yeah, I think that is it.